Moving on to question 4, we have this question. The diagram shows the curve with parametric equations for minus half pi to half pi, and we have x is equal to tan theta and y is equal to cos square theta. And in part A, we're supposed to show that the gradient of the curve at the point with parameter theta is this. So as I'm sure by now, we all know that gradient means dy over dx. So that is what we have to find here. We are finding dy by dx. And since we have parametric equations, we are going to need to differentiate these separately. So we will have dy and dx. And we need something that is linking both of them. So we can see that we have theta in both of these equations. So we will write dy by d theta and d theta over dx. So firstly, let's differentiate the equation of y. We have y is equal to cos square theta. And to get dy over d theta, we know that we will bring the power down as the coefficient. So this will be 2 cos theta, and the power of cos will turn into 1 because when differentiating we decrease the power by 1, and then we have to multiply this with the derivative of the equation, and that will be minus sine theta because the differentiation of cos is minus sine. So the concept over here is that we know if we are differentiating something like this, that the power will come down as the coefficient and it will be decreased by 1. So when we're differentiating trig, we know that we have to do the same thing, which is why we got 2 cos theta, and then we have to multiply it with the differentiation of the trig. So we have gotten dy by d theta as minus 2 cos theta sine theta. And now we need to find d theta by dx. So as you can see, we have x is equal to tan theta. So we can find dx over d theta, which would be sec square theta. And that is 1 over cos square theta. These differentiation rules is just something that you need to know beforehand, and you will get to know by practice. So we know that in this equation we need d theta over dx. So how do we change that into this? We will just be flipping this over. So we can conclude that d theta over dx is cos square theta over 1. Now we will take this into our main equation. We have our two expressions, and we will write dy by dx is equal to minus 2 cos theta sine theta times cos square theta, and we will achieve the answer minus 2 sine theta cos cube theta. And this is exactly the same as what we were supposed to show. So that is our correct answer. Now let's attempt part B, where we have to find the exact value of the x-coordinate of P. What is P? The gradient of the curve has its maximum value at the point P. So the idea here is that, say you've been given a curve equation of y and say that it has a maximum value at m. So we know for that dy over dx will equal to 0. Now again, over here, we've been told that the gradient of the curve has its maximum value at the point P. So in this scenario, dy over dx has a maximum point at P, we have been told. So d square y over dx square should equal to 0. And basically the concept here is that if they say that there is a stationary point, then we know that dy over dx will be 0. But if the gradient has a maximum value, then the differentiation of that will equal to 0. I hope you understand. Now let's proceed. Okay, so now from the first question, we know that dy by dx is equal to minus 2 sine theta times cos cube theta. And we can see here that these are two things being multiplied, so we are going to use the product rule. And the product rule is that dy by dx is equal to u prime v plus v prime u. So we can say that u is equal to minus 2 sine theta and v is equal to cos cube theta. So if we differentiate u, we will get minus 2 sine theta is to the power 1 right now. So if we decrease that by 1, it will become to the power 0. And the differentiation of that is cos theta. So if we simplify this, that this will become 1. So it's essentially just minus 2 cos theta. Now for this one, if we differentiate cos cube theta, that would be, we would bring the power of 3 down as a coefficient and decrease the power by 1, so that is cos square theta, and multiply it by the differentiation of cos, which is minus sine theta. So if we simplify that, we get v prime is equal to minus 3 cos square theta times sine theta. And let's put that in our equation over here. And we have u, v, u prime and v prime. So let's put these and we will get dy by dx is equal to u prime, so minus 2 cos theta times v, which is cos cube theta, plus v prime u, so minus 3 cos square theta times sine theta times u, which is minus 2 sine theta. Now the minus and minus over here will cancel and make a positive. And let's simplify this further. So we will have minus 2 cos to the power 4 theta plus 2 sine square theta and 3 cos square theta. Now I deliberately did not multiply the 2 and 3, and that is because we can take common with this 2 and this 2 and cos square over here and cos square out of this, because cos to the power 4 is essentially cos square times cos square. So we will take positive 2 cos square theta common, and we will be left with minus cos square theta plus 3 sine square theta. And this is equal to dy over dx, but that is equal to 0. So we will have two answers now. 2 cos square theta is equal to 0 and 3 sine square theta minus cos square theta is equal to 0. So let's solve these now. Let's take a look at our graph first actually. So we can see that the value of x lies behind 0, so it is a negative value. So that is what we are looking for. Let's try and solve for theta first. So we're going to divide the 2 on the other side and get cos square theta is equal to 0. And if you under root 0, you still get 0. So cos theta is equal to 0. And the inverse of cos 0, if you put in a calculator, is, it is 90 degrees. But we need to check all of our quadrants. So the question said that this equation is for minus half pi to half pi. So pi is basically 180 degrees. So half of that would be 90 degrees. So 90 degrees and minus 90 degrees. So let's take a look. So our other value for theta will be 360 minus 90 degrees, which will be 270 degrees. So theta is equal to 90 degrees and 270 degrees for this one. And then let's take another look at this one and see what happens, what value we're getting from this equation. So I'm going to send the cos square to the other side, and I can see that if I do sine square over cos square, I could get tan square. So sine square theta over cos square theta, I had 3 here and this will equal to 1. Then I will be left with tan square theta. I will send the 3 to the other side to get divided, and then we will do tan theta is equal to plus minus under root 1 over 3, because when we are doing under root, it is important that we take two values with both signs. Now we know that tan is positive in the first and third quadrant when it is positive, and tan is positive in the second and fourth quadrant if it is negative. But our question is from 90 degrees to minus 90 degrees. So if we take a look, that is the first quadrant and fourth quadrant. So we do not need to take a look at this or this. Let's find tan theta is equal to 1 over positive under root 3, and if we use a calculator to find the inverse of that, we will get theta as 30 degrees, and that is our first value. Now if we take tan theta as negative 1 over under root 3, the way to do this, also we're only looking at the first quadrant for the positive one, right? I hope we understand that. Now for negative values, it's easy to find theta if we do theta is equal to 360 minus x, and x being the tan inverse value of what we are finding. So that was 30 degrees. So we will do 360 minus 30 degrees, and that gives us 330 degrees. But we can also write that as minus 30 degrees, because we know that if this is 330 degrees, this is negative 30 degrees, because it's the same acute angle, just in the opposite direction. Now we know that x is supposed to be a negative value, and so we got theta as 30 degrees. So let's check what happens when we put that into our x value. So if you put x is equal to tan 30 degrees, we will again get what we got in the first place, 1 over under root 3. But we were going to reject this value because we can see this is positive and we need a negative answer. So I will instead try the other value I got for theta, minus 30 degrees, and then I will get tan, the exact value would be minus 1 over under root 3. So now we know that we are going to reject this value and this value for tan that we got earlier, and instead we are going to accept this value for theta. So finally we will put this back into our main equation, and we will get the exact value for x to be negative 1 over root 3, and that is your part B.